Hey guys, in this video I'm just going to show you how I put my selfie wings together for the Christmas show this year. The idea here is I wanted the wings to be independent from the show when people interact with them, but I also wanted the wings to be a part of the show when the show was playing and no one was touching the wings. So we'll just start off the controller. I've just done a pinwheel here. This would be indicative of the main show with all the music and everything playing, effects, whatever. These 5 buttons are lit up, so someone comes up and they want to try an effect, they can press it and it'll take the wings off the main show. And then they can press another button and it'll just cycle through. And as you'll see, my wife's still working on these sequences, so these are just placeholders. And then people can take their photos. I've got it set for 12 seconds before it kicks back in, but obviously you can set it longer and it should flick back in now. And there we go, it's back on the main show and the control panel resets itself. So this way the wings don't stand out when people aren't interacting with them. And then when someone comes up, it'll switch it to a sequence. They can take their photo and then move along, and then it'll go back into the show. So yeah, that's the idea I had for this setup anyway, and this is just using a dedicated Raspberry Pi in a box to control it and have its own sequences, and I'm just basically flicking it out of the main show and into the dedicated Raspberry Pi with a sequence playing. And then once it's finished, it'll flick back into the main show again. And I've written a script to do this for FPP, and I've got a wiring schematic of how I've set it all up. I'll just grab the controller now and show you sort of how I've put it together, and then I'll show you how I went through setting it up in FPP. Okay, the controller is fairly simple. You just got your 2 data ports out, one for each wing, and then a couple of power inject ports, and then RJ45 connection for the controller. And then I've also put a smart receiver in here, so I can run a RJ45 with a cat cable to this to run it from a smart receiver in there. But I've also got just your standard pigtail ports from my main controller, so that's just your standard WS2811 data that comes in. So I've just made it so I have a couple of different options, and then I can just switch between the smart receiver or the pigtail ports as the input there. And then basically the board's just in here. So in here I've got a Raspberry Pi. It is a 12 volt system, so I have a voltage regulator to step down from 12 volt to 5 volt for the Raspberry Pi. I've got 2 relays to switch between the data that comes in from the main controller and the Raspberry Pi. So that's what switches between the 2 shows. And then a level shifter in here to take the 3.3 volt logic of the Raspberry Pi and step it up to 5 volts. If you had a Pi hat on this, you wouldn't need this level shifter, so you could use a Pi hat here if you wanted to, but I don't have one of those, so I just use a level shifter. And then there's just a smart receiver there which is connected to the RJ45, and then an F8 distro with an LRS 350 12 volt power supply, and then that all just sits in there. I've got screws to hold that there, and then that just sits there, and then the lid goes on. So it's a fairly simple build. I've just got a vent on the side and another vent there. Nothing too amazing about it. And yeah, that's the box anyway. The controller's fairly simple. It's just laser cut acrylic with the 5 big dome push buttons on it. RJ45 input, so I can connect the box with the control panel. And then there's fairly simple in here. Doing it like this has no electrics up near where people are playing with it, so this just has 5 volts, so that's the only electric that's up here. So all of the high voltage stays in the box, sealed, hidden away, and then this is basically just switches and LEDs, so there's nothing too fantastic in there. It's fairly basic. But now we'll get on to having a look at FPP. So okay, here we'll go to my GitHub page, which is DNG Craft, and then we'll go into the Selfie Wings distro. And in here it has all of the files and stuff, so in here you've got wiring schematics. So this is how I've wired it up. This is the 12 volt system wiring. You've got your buttons here, your Raspberry Pi header, your level shifter, relays, and then this is just your input, so it could be an ESP, straight pixel data from your main board, or a smart receiver, well, whichever one you like to do. And then the voltage step down to 5 volts. If you've got a 5 volt system, you don't need that step down. And of course, if you've got a Pi hat, you can get rid of the level shifter and probably not worry about some of the GPIOs there, but this is how I've set it up anyway. And then we'll go back to the main. So here's the FPP script, which I've named run sequence, so you just download that. And basically in here, it's fairly simple, just your relay GPIO, your LED GPIO. If you follow the wiring diagram, you don't need to change any of that. And then default runtime, you don't really need to edit anything here because the arguments will all be passed to the script. And then some of the 3D printed parts that I used, and then some of the laser cut files that I used as well, and also some of the parts that I used down here. So we'll go to the FPP on the control box, and in content, setup file manager. I named all of the sequence files to the buttons, so blue button, green button. That's just an easy way to identify what sequence is going to go on what button. And then in here you upload that script, which is run sequence. So that's all uploaded, and then you go to input outputs, and then select Pi hat, and then this is where I've set up the Pi hat. Well, it's not a Pi hat, but I'm using the GPIOs. So once you enable Pi hat, you can use GPIO 18 and 19 for pixel data, and just basically left wing and right wing. And then because I've got 500 pixels on each wing, it'll be start channel 1 pixel count 500, and then start channel will be 3 times 500, so it'll be 1501, and then again another 500 pixels. And I've just set it at 30% brightness. Go down to GPIO inputs, and this is where you configure the script. So you come down here and you go to these bottom 5, well there's that one there, but don't worry about that. You come down to the bottom and it'll be GPIO 13, 16, 26, 20 and 21 that I've used. You set them all to pull up, and then I've just named each one for the button again, just so I can identify it. Red, green, blue, yellow, and you get the idea for the description. And then over here the command will be run script, so you come down and you find run script, and then you'll get this option which will be script name, so you select run sequence, and then here is the arguments. So what this is here is this is the name of your sequence. So before I showed you I named all of the sequences after the buttons, so you put the sequence in here without the .fscq extension, so it's red button, green button and so on. If you have spaces in your sequence name, put quotes either side of it, and then you can have spaces in there, or the arguments won't work properly. So yeah, just remember if you've got spaces to put quotes either side, and then this 12, that's the run time. So this is the time that you want to have before the relay kicks back to the main show. I had it set on 12 seconds. 120 is what I'm aiming for, about a 2-minute sequence. 2 minutes for someone to take a photo, maybe extend that a little bit, but 120 seconds is what I'm going with. And yeah, so you set the time there, and obviously you will make your sequences to the same length or a little bit longer. The script will stop the sequence playing and blank out the lights, so it can be longer, but if you have it shorter, the sequence will end and go black and there'll be nothing until the relay kicks over. So just make sure that you know how long your sequence is, and just make this, a second shorter, and you should be good. You won't notice the blanking. And one last configuration that you need to do is you need to go to the SD card of your Raspberry Pi and find config.txt, and then just scroll down to the bottom of it, and you need to add this command here. What this will do is it'll set the pin low and turn the LEDs on for the button controller, so it'll light up when you boot the Raspberry Pi. If you don't add this command here, it'll the buttons will be unlit until one of the buttons is pushed, and then it'll set the pin low after. So if you just come into your config text and just add that text there, which is just GPIO equals 27 equals output, and then setting it drive low. So yeah, that's the last little config that you need to do, and then you should be good to go. And yeah, the other thing about this configuration is if the script will reset itself. So if someone presses the button and it, say you've got 30 seconds and 19 seconds in, they press the button again, it'll reset the time to 30 seconds again each time it plays the sequence. So you don't have to worry about, someone pressing the button and then 5 seconds later it flicking back because a timer was set or something. Each time you press the button on the controller, the time that it plays is reset. And yeah, so that's pretty well the basics of it anyway. I've got a smart controller inside of the box at the moment, which uses the RJ45, which I showed you, but I'm actually thinking about maybe swapping that out for an ESP and then running WLED on it for a wireless communication, and then I'll only need to have a power cord run out to the power box, but I'll experiment with that later. My idea was I didn't want the wings just really standing out and playing sequences or taking away from the main show, or sitting there dark when you can light them up. So having it switched between the two shows I thought was the only real way to do it. But yeah, anyway, I hope this helps you set yours up.